Good morning, Science 20s. Our lesson today is on velocity. If we remember, speed is the distance traveled over a specified time, and we called that average speed because ideally on a longer trip, we're probably not going to be driving at exactly the same speed the whole time. Therefore, we're going to average out over that distance, over that amount of time to get to our average speed. Velocity, however, is not dependent on distance. Velocity is dependent on something called displacement, meaning what is our change in position from where we are now compared to where we started. We will notice that for velocity, it's a vector quantity, therefore it's got a vector arrow. It also uses displacement, which is a vector quantity with a vector arrow. So direction will be important. Let's look at some examples. A Viking runs the football 30 meters right, then 25 meters left, then right another 15 meters. If it takes him 12 seconds, what is his average velocity? So in this question, I think always the easiest thing to do in all these questions is to draw a quick little sketch. So going to go to the right, 30 meters. We're then going to go to the left, 25 meters. We're then going to go to the right 15 meters. Now, when I go to figure out displacement, displacement means we take into account where am I now with regards to where I started. So since we went to the right, that's going to be a positive 30 meters. Then we went to the left, so that's going to be a negative 25 meters. Then we went to the right again, so that's going to be another positive 15 meters. When I go to add this up, 30 plus 15 is 45, minus 25, we are going to be still positive 20 meters. Or another way to think of this is, here is where I ended up, here is where I started. Of course, we are positive or to the right, and we are to the right or positive 20 meters. My total time for this movement, it tells me in the question, is 12 seconds. And my job is to find the velocity. Yes, the vector arrow is important. So my formula from the formula sheet is velocity equals change in displacement over change in time. My change in displacement is positive 20 meters. My change in time is 12 seconds. Therefore, my velocity is going to be positive 1.7 meters per second, or 1.7 meters per second east. When I go to mark this, you would get 1 mark for calculating displacement. You would get a mark for the formula you used. You would get a mark for substitution. Have to include the direction on your displacements because it's a vector quantity. And you would get a mark for either one of these answers. It's got a unit attached, and in both cases, it has a direction. First one, it's positive. Second one, it's east. They both mean the same thing. So this question would have been out of a mark of 4. Okay, let's look at another question, shall we? Now, in this question, Super Grover flew to Gordon's Creek. So Super Grover started right here and he hit his cape. He then walked to Dorothy's Creek, which would be, so from there he went to here. And that was 2.6 kilometers. So I'm just going to make this darker. And 1.5 hours. When at Dorothy's Creek, he had a picnic for 30 minutes, so that is 0.5 hours because we want all of our units in the same. So we're going to change to hours. And then from Dorothy's Creek, he walked to Williams Lake, and that would be back this direction. And so that would have been 2.6 plus 2 is 4.6 kilometers. And it took 2.5 hours to do that. Perfect. So that's what I mean by let's set up our picture. We got lots of information on there. Now we can understand what's going on in the photograph. So to calculate displacement, vector quantity. So we're going to care about direction. Well, displacement is where are we now with regards to where we started? So we went 2.6 kilometers to the east, so that's a positive. We then went back 2.6 kilometers and then back again or I've already done the math on here. We went west or back 4.6 kilometers, so that's negative. So when we add these together, this is going to be a negative 2.0 kilometers, or it's going to be 2.0 kilometers west. Because remember, I started here, I ended up here. So I am west of my starting point of where Grover landed. I'm going to calculate my average velocity. Again, to find average velocity, I could make a list of variables again. So we already know displacement was negative 2 kilometers. My time, and we just have to add it up on my picture, 1.5 hours. We then did a half hour for a picnic, so now we're at 2 hours. And to walk all the way back here is another 2.5, so that is 4.5 hours. We are trying to find velocity. So velocity equals change in displacement over change in time. My displacement is negative 2.0 kilometers over 4.5 hours. And when I calculate this, I'm going to get a negative 0.44 kilometers per hour or 0.44 kilometers per hour west. If I was to assign marks, I would get 1 mark for calculating displacement, 1 mark for the formula to find velocity, another mark for the substitution with the correct time included, and your last mark is for getting the correct answer with a unit with a direction attached as well. Okay. On the last question, what I would like for you to do is try this question for yourself. Pause the video, try getting all 4 answers, then unpause the video to check your work. So Bert and Ernie traveled from base camp, so that would be right here, to Scalzo's Creek. And we already saw that that is 5 kilometers. And it says we can do that in 2 hours. We then fished for 1 hour in the creek. And then from here, we traveled all the way to Michael's Creek. So that is all the way up here. Not very good at drawing a straight line. And so we have to add this up. So this would be 5, 7, 9.5, 12, 13 kilometers north. And it said 5 hours. Perfect. So now let's answer the question. What is their distance traveled? So to calculate distance, everywhere that Bert and Ernie traveled, we're going to add up. So they went 5 kilometers to go south. And then they went another 5 kilometers, 2 kilometers, 2.5 kilometers, 2.5 kilometers, 1. Now I've already done that calculation, so I'm just going to add 13 kilometers. We do not have to worry about which direction we're going because remember, this is distance. This is just everywhere Bert and Ernie physically stepped. So when we add 5 plus 13, this is going to be 18 kilometers. What is their displacement? Meaning, if they are now here and they started here, what is this displacement? We know it's north of where they started, so let's calculate this. This is when we're going to care about directions. So when they first did their first 5 kilometers, that was a negative 5 kilometers because it was south. And then they went north 13 kilometers, so that's going to be a positive 13 kilometers. So when we add these two numbers together, this is going to be positive 8 kilometers or 8 kilometers north. Now, we'll notice this question says average speed. In order to determine speed, we need distance. So, speed equals change in distance over change in time. So, my distance we've already calculated to be 18 kilometers. My time is 2 hours, 3 hours, 5 hours. That's going to be 8 hours. 18 divided by 8. The average speed of this trip is 2.25 kilometers per hour. Now, that is going to be very different than finding average velocity. Remember, to find velocity, velocity is dependent on displacement. So we're going to use the displacement over time. So I'm going to put in positive 8.0 kilometers over. The time of the entire trip is still 8 hours. Positive 8 divided by 8, this is going to be 1.0 kilometers. Positive, need a direction, or 1.0 kilometers north for the velocity. Ooh, I goofed. Let's put the correct units in here. Kilometers per hour. Good thing I checked my work. So if I was to assign marks on these questions, you would get 1 mark for distance. You would get 1 mark for displacement, must have a unit attached, whether that's positive, must have a direction attached, whether that's positive or north does not matter to me. Average speed would be formula, substitution, answer, and velocity would be formula, substitution, answer. Again, we're looking at having direction.